Dear friends, forensic experts are usually asked to retrieve unstructured or deleted files, hidden data as in case of steganography, encrypted data which may link the criminal with the crime. So, recovering and reconstructing all this information can be of utmost importance, which is quite tedious job and requires a thorough knowledge about the file system and the extensive experience regarding the same. So, let us know what is file system and its importance. What are the different types of the file system? So, let us start. I am Dr. Navjot Kaur Kanwal. Dear friends, as you know, there are wide variety of storage devices where data can be stored, like in case of internal and external hard drives, memory cards, USB flash drives, CD, DVD, etc. Data is stored on them in form of files, which may be a text file, video file, audio file, data file, image file, program file, and all are stored as files. They are systematically organized on the disk so that can be easily retrieved when needed. So, all you know that computers are not restricted till calculations. We create Word documents, we listen to music, we play videos, we do research and generate a lot of database. So, modern computer has to store many different types of the data in form of text, audio, video, images, and even physical quantities like light, sound, temperature and pressure. Again, all of them are stored as files. But how these files are managed in storage devices and who is taking care of all this system? We refer this file management as file system, which is a method of organizing, storing, retrieving and even updating the files from a storage medium. In order to keep files organized, there are folders like we use for handling our documents in day-to-day life, which are further managed by directories, or you can say that a system of directories and several level of subdirectories is called the file system. A file system provides a means to organize a drive. It specifies how data is stored on the drive and what type of information can be attached to the files, like file names, permissions and other attributes. For instance, think storage media like a big library where books, journals, magazines, research articles are kept, where different classification systems are used to arrange the books. Similarly, file system is a manner in which files are named and logically arranged on storage media. It is like index page that contains the physical location of every single piece of the data on the respective storage device. Now, how a file system knows which file is to be located? So, remember, to locate a file system uses a path from directory to subdirectory to folder and to the file. For storing and retrieving files, the file system makes use of metadata, which specifies the date of creation of file, when it was modified, file size and so on. That means operating system need not to find the whole drive for locating a file. It just has to go to the file system. Let us see how files are arranged on the storage media. Dear friends, we talked in length about storage media and we learned that the hard disk constitute of different tracks, which refers to the circular path on the surface of disk. Each track is divided into different slices like on the pie, called as the sectors. These sectors act as the reference point for storage. So, whether it is hard drive, optical disk or floppies, each sector stores a fixed amount of data, usually 512 bytes for hard disk drive, 2048 bytes for CD-ROMs and DVD-ROMs, etc. Now, in reference to storage, we also mention about blocks, which is a group of sectors that the operating system can address. A block may be one sector or a combination of 2, 4, 16 to 128 sectors. Files are stored at the start of the block and usually take up the entire block. And it is important to mention that due to the continuous deletion and rewrite system, also called the file system aging, the file system lay out the contents of the files in non-continuous manner called as data fragmentation. Again, it is the duty of this file system to identify the vacant sectors to store a file of given size, and it has to continuously keep a record of used and unused sectors, size, position and name of the files stored, or you can say a file system is a structured representation of data and a set of metadata where files are read by its position and size. Different file system is used in different operating system, which means that if a program is built for Windows, it will not run on Android because programs are also dependent on the file system. Windows mainly support three different type of the file system. They are FAT32, extended FAT and NTFS, whereas Mac operating system uses HFS plus and don't work with Windows, whereas Linux has its own file system. But why so many file systems are there? This is because every user has its unique requirement. So, to fulfill different requirements such as storage arrangement, durability, reliability and consistency, large number of file systems are developed to serve different purposes efficiently. Some are dedicated file system. For instance, the ISO 9660 file system is designed specifically for optical disks. All of them are greatly vary in the way the data is organized. Some are faster, having the additional security features, and some support drives with large storage capabilities. Some file systems are more robust and resistant to the file corruption. Although it is very difficult to have all the characteristics in a single file system, but each operating system develops its own file system to fulfill all these criteria. Let us now go through the file system of different operating systems one by one. We will start with the various file system of Windows like FAT, extended FAT and NTFS. FAT or the file allocation table. As earlier mentioned, that file system is responsible for keeping a record of all the files stored on the storage media as per their size and position in a systematical manner, where FAT is one of the oldest and simplest file system used by operating system to keep a record of all the files. It was introduced in 1977 and has its origin from DOS, the disk operating system. File allocation tables keeps the record of all the scattered part of the files due to fragmentation. It can support long file names with full file path being as long as 255 characters followed by file extension. File name should start with alphanumerical characters. File and FAT are further stored in directories, where each directory is an array of 32 byte records. Let us see how different attributes of files are recorded in file allocation table. Let us now see how different attributes of a file are recorded in a file allocation table, which contains an array of block descriptors. The key design in file allocation table is that Each file is represented as a linked list of blocks, where the last part of the block gives the idea of the location of the next block. This also specifies that whether a block is occupied or not, like a zero value indicates that the block is not used, where the information regarding the starting block of a particular file is stored in directly table format along with the metadata. There have been many versions of file allocation table like FAT12, FAT16, FAT32, where the number 12, 16 and 32 refers to the number of bits used to specify a file system block. FAT12 and FAT16 were exclusively used for floppy disks, but almost obsolete now. FAT32 is also an old file system which has introduced in Windows 95 in 1995 and replaced FAT16 file system. It is still prevalent for memory cards, digital cameras, USB drive and other portable devices. It provides a better usage of disk space and more storage efficient and support up to 2 terabyte of size. A highly compatible system works with all versions of Windows, Mac, Linux, game consoles and practically anything with a USB port. Since it had a drawback that it could support a maximum of 8 terabyte of partition size. To address this issue, exFAT was introduced, which does not have any realistic limitation concerning with the size of the file or partition. exFAT, that is Extended File Allocation Table. It was introduced in 2006 and optimized for flash drives without the limitation of FAT32 and can manage file system created on huge partitions. It was early used in Linux systems. Extended 2 is probably one of the most widely used Linux file system. Talking about the compatibility, it works with all versions of Windows and modern versions of Mac operating system X. Considered safe file system in the sense that the files are immediately overwritten when deleted with random data to prevent someone to gain access to the previous data, but its optimal use is advised when you need larger file size and more partition limit than FAT32. Then there is NTFS, the new technology file system, the most prevalent type of the file system used in modern version of Windows by default. Introduced in 1993 with Windows NT, a comparatively new type of the file system which is much more efficient, secure than its forerunners. FAT32 and support a lot of new features like file compression, journaling, access control, encryption, etc., but show less compatibility with other operating systems. In NTFS file systems, files are stored as a file descriptor in master file table, which contain all the information regarding a file like size, allocation, name, etc. The first 16 entries of the master file table are retained for the bitmap, which keeps record of all free and used cluster. It is also retained for the logs used for journaling records and for the bad class containing information about the bad clusters. The first and the last sectors of the file system contain the file system settings like the boot records or the superblock. NTFS uses 48 and 64 bit values for referring files, thus being able to support data storage with extremely high capacity. This is a good option for Windows servers line as provide a good folder and file security by allowing permission for files and folders. Files and partition size are larger in NTFS than those of FAT. It can support files from a range of 4 gigabytes to 64 gigabytes, and partition can be of a size of larger as 16 exabytes. It is highly preferable file system because it provides access control for every file and folder in the list, a reliable and recoverable file system which makes use of transaction logs for updating files and folders automatically, and it also provides bad cluster mapping, means it can detect bad clusters or erroneous space in the disk, retrieve the data in those clusters and then store in another space. Then there is REFS or the Resilient File System, which is the latest development of the Microsoft introduced in 2012 with Windows servers. It has altogether new type of the file system and is mainly structured in the form of B plus tree. This system is highly fault tolerant with lot of new add-on features. Let us now look at the file system of Linux. Open source Linux aims at implementing, testing and using different type of the file system. The most popular file systems are Extended, Extended 2, Extended 3, Extended 4, a native of Linux file system. Since open source, it undergoes continuous development and improvements. Extended 3 file system is just an extension of Extended 2 that uses transactional file writing operations with a journal. Extended 4 is further development of Extended 3, extended with the support of optimized file allocation informations and extended file attributes. Where Razor file system is a good substitute for Linux. It is a generally type of the file system and has speciality of handling large number of small files and used as the default file system in number of Linux distributions. Then there is XFS or Extends file system, referred as the next generation file system, a high performance 64-bit file system created by Silicon Graphics Incorporations in 1993 and was the first used in Unix based IRIX operating system in 1994. Again a journaling type of the file system which keeps a track of the changes in log before committing the changes to the main file system. Then there is JFS or the journaled file system, initially built by IBM for its own computing system, but presently it is an open source file system and employed in most modern Linux versions. Then there is Butter or BTRFS file system, which is an abbreviation of B-tree file system, is a file system based on the copy on write principle, a technique which efficiently copies data resources in a computer system. This file system was originally designed at the Oracle Corporations for be used in Linux. This advanced file system with add-on feature is highly fault tolerant and reliable. Let us now have a look on the various file system of Mac operating system. Apple's Mac operating system mainly uses two file systems, the HFS Plus, an extension to their hierarchical file system used on old Macintosh computers, and recently released APFS. The HFS Plus used to be the primary file system of Apple desktop systems, including Mac computers, iPods as well as Apple X server products. Now it has been replaced by APFS in Mac operating system High Sierra. The HFS Plus file system uses B-tree for placing and locating files. The information regarding tree and the used allocation blocks is kept in the allocation file. The APFS or the Apple file system is the proprietary file system for Mac operating system, High Sierra, and later. It works efficiently with modern flash drives and solid state drives. It is 64-bit file system, highly efficient, uses again the copy on write method and offer a lot of data integrity and space saving features. All the file contents and the metadata about files, folders along with the APFS structures are kept in the APFS container. Then finally, let us see what are the file systems which are used in BSD Solaris's Unix operating system. The most common file system for these operating system is the Unix file system or the UFS, also often referred as FFS, the fast file system. Then there is clustered file system. In modern computing technology, where there is a more and more trends of distributed storage, so clustered file system has come in fashion, like zettabyte file system, the ZFS of the Sun Solaris. Likewise, there is virtual machine file system, there is Red Hat Linux global file system, etc. A clustered file system is shared as it is mounted on multiple servers at the same time. Therefore, such file systems are highly extensible. Dear friends, let us now summarize and conclude. The file system is used to manage data by storing, retrieving and updating data. We discussed about the different type of the file system being used by different operating system. The most conventional file system used nowadays are FAT32, NTFS and HFS. If we talk about the ideal feature of a file system, it should show compatibility with multiple versions. There should be file permission for security purpose. It should quickly recover errors in case of system failure. Should keep copies for the backup, follow encryption. There should be well defined partition size limit, etc. So, there is always room for improvement. Therefore, the system developers are always in the process in developing a file system which is faster, more stable and more scalable for large storage devices and have better feature than its earlier systems. Having the thorough knowledge about the file system is helpful in digital forensics to find the deleted or hidden files from the media. A hidden file which may lie in any area of the digital media or disk like slack space, unallocated cluster or lost cluster can be traced by file carving. Data can be extracted, reconstructed using a variety of available software tools that are based on various algorithms such as bottom-up tree reconstructions and inference of partition geometry. Reconstructed data is thoroughly analyzed for preparing report to be presented in the court. So, dear friends, I stop here. That's all I have for today's lectures on file system. See you in the next module. Take care. Goodbye.